was working 8 years in Infosys also. 2008 to 2016, he was working as a technical analyst in Infosys campus. So now we are grateful to have such a person. So I would like to welcome Dr. V. Chandrasekhar sir. Later, sir, I request you to give the project. Thank you, sir. So now the session we take over from the Chandrasekhar sir. So hand over to you, sir.
So good morning all. Today we are going to discuss about applying PySpark data analytics, streaming data. So we are getting streaming data. So what is going to be streaming data? I'll see you somewhere. Any conference. So what is going to be streaming data? The expect some scenarios where we get continuous data every second, every millisecond. Other conditions. Other reports where we deploy sensors in the fields. So sensor sends the data and keep on pushing the data to the network for the network integrating data and we need to process. Software prediction. Okay. Wherever every there is change in the data, transaction, millisecond or second wise, we call it as real-time data. Satellite. So images from satellite every millisecond when we are checking the progress. Okay, so in warfare, in war, okay, so we get sensors, so we will get satellite view images. So you call it, okay, sensor data, navigated feeds with other sensors. So they will sense the data and every second they will push the data. So all these scenarios required as a real-time data. So how much data we will get per day? Per second itself, we are getting huge amount of data. So if you collect that per day, how much data we get? Then how to process it, how to summarize it, how to extract information from that data, how to visualize it. Can you think of which are the tools we need to use? Suppose you have data from DMart. Every second there is a transaction, right? DMart we have 10 to 15 boards. So you will go and you will submit your goods, they will do the billing. Like that in Mysore, we have 2 3 DMarts. So every second you will get the data. At the end of the day, you need to summarize. The owner wants to summarize how many receipt models, how many metrics. So how you do that? Huge amount of data. It's not a simple classroom data, marks, but it is live data. At the end of the day, you want to summarize. So how to process it? Which are the tools we need to use? Tools. No, madam. Okay, study is different. Which are the tools we need? So that is what. When you are dealing with IoT, Internet of Things, what is Internet of Things? Small devices. So Internet of Things means you will deploy every or almost even 10 cap also source of data. You will deploy sensor, it will give you the data. That's what IoT. What Internet of Things? Every device connects to the internet and you will deploy everywhere, wherever you want, you will deploy, it will give you the data, it will send the data to the centralized server. From the centralized server, you need to process. What you will process, that is next step. Okay? So when you are dealing with IoT, so it generates huge volumes of data. Maybe 10 rows. In terms of Excel file, it will be 10 rows. So how to process it? Okay? So we have earlier MapReduce, Hadoop, etc. But now Spark. Spark is one of the tools which will help us to process live data, real-time data. So when you want to deal with IoT, so you must know which are the tools we can use to process the huge volumes of data. Okay. Next slide. So Apache Spark is what? It provides a set of tools, okay, so that we can process real-time data. So in those who are doing the research PhD also, so if they want to do on IoT, so they must be have good exposure on the good transport Spark. Because first they need to process the data. Without processing the data, then if you use normal techniques, it will be normal data. So when you claiming that it's IoT data means voluminous data. So how to process the voluminous data? So those tools you must practice deploy. Nowadays everything is free, open source. So you don't need to verify Spark is Apache Spark is also open source. So you can use it and you can try to process the data. And one more advantage is that because of Python is having API to almost every complex household. So you know, because to code in Apache Spark may be a complex thing, but when you use PySpark, it makes the thing simpler. It provides the API which makes it simple and it will connect to the Apache. So Apache is the backend, you will have APIs. Those APIs are from the Python. So life will be easier. Next. So we are going to study, okay. So before Spark, which are the technologies we are going to use and why we need Spark and what is Apache Spark, okay, and various specifics about the Apache Spark. I will have demos. Okay, so once we run the demo, then we come to know. Okay, the tools we have to practice. Programming languages we have to practice. So if you anything nowadays what happened, completely we have to do hands-on. Theory you can learn on your own. If you go to anywhere, okay, you can type. PySpark you will get a number of PPTs. But getting hands-on, getting an idea is what important. Learning any language is also the same thing. If you read, keep on reading, you won't get anything. You have to practice. Okay, hands-on makes you things clear and easier. Okay, so we have demos. In the demos, we will discuss in brief about how to deal with the real-time data, streaming data, and how two units will communicate, two processors will communicate. Okay, all those things. Next. Okay, so before Spark, we have Hadoop, Star, okay, Mahout. So all these are the various technologies are available where they are using to process huge volumes of data. So mainly we focus on batch processing, stream processing. What is batch? What is batch processing? Batches. So you may have 1,000 rows. So first I will take 100. Every 100 I will try to summarize. I will get the data. Okay. Next, stream processing. What is stream processing? As and when I receive the data, I keep on processing. Okay. So like that, we have interactive processing, a graph processing, machine learning. Okay. All those things. See now Spark. So is it visible? So 100 times faster than Hadoop. Because when we are dealing with huge volumes of data, first thing. Second one is real-time data. What is the main expectation? Accuracy or speed? Which one you want? Which one you give a preference? Suppose both are not possible. Highest accuracy, highest speed processing is not possible. So which one you select? Speed. Because if I am giving the output per hour, my accuracy is 98%. Suppose I am giving you output every second, my accuracy is 95. Which one you prefer? Majority speed. Because getting an output per hour, Okay, so I will lose data also. So here as I'm seeing that every second I am giving the output and my accuracy is less. And I am giving output for every 1 hour, but my accuracy is 98%. So generally there will be a trade-off between the speed and the accuracy. But in general, people need accuracy. In real-time environment, production environment, okay, they have to make a decision. Okay, Samsung or in production Toyota or manufacturing company, any manufacturing company, immediately they have to take a decision. They cannot wait for 1 hour. In those scenarios, speed is given importance compared to the accuracy. But accuracy should not drop too much, but a little bit accuracy drop in accuracy is permitted. Okay, so 100 times faster than existing older technologies. Next, automatic memory management. So because huge volumes of data, so they have to manage. Okay, next, recovery automatically because huge volumes of data. So failure is unavoidable. We cannot avoid failure, but if any node is failure, how to make it run? So all those things it has to take automatically. Okay, without human intervention. Next, time-based window criteria. Time-based means every 5 seconds it will process the data and use the output. Diverse processing platforms process everything exactly once. Whenever it receives data, it processes the data exactly once, so that it is able to process all the data faster and able to generate the summary. Okay, so what are the advantages? Speed, memory management, fault tolerance, window criteria, processing, and duplicate elimination. So even though you will have multiple records, it will eliminate the duplicates and it will process those duplicate records only once. Okay. So these are the properties. I will share the PPT, so no need to worry. So what is Apache Spark? So Apache Spark is an open source, available freely, distributed cluster computing. So what is cluster computing? Group of systems share the load, they will process the data, they will compile, and they will give the results. Why we need cluster computing? Why we need to group the computers? Because we are dealing with 1 crore rows. So to process those rows, single computer cannot handle. Even though it can handle, the output is slow. So to achieve the faster output and to process all the records, definitely we need to combine the nodes and cluster computing. Nowadays, almost if you are working with any data, the minimum expectation is what cluster computing. Because cluster means more than one node is working together, there is a chance of load failure. So automatic load balancing, all factors needs to take care. Load balancing, next automatic recovery, all those things needs to be taken care. Okay. So it is a general engine for big data analysis, okay, processing and computation. So it is built for high speed, process the data very speed. Okay, and ease of use offers simplicity, stream analysis. Main thing is stream. Stream plus IoT. IoT means, as I said, connection of sensors. You will deploy wherever you want, you want to in agriculture, wherever you want, you can deploy these sensors. Each sensor will sense the environment and generate the data. The data we call it as stream, real-time data. So that real-time data, we are calling it as a stream. So we use it and we use this Apache to process it. Okay? So it can analyze data in real time. It provides fast computation over the big data. Okay, please go through it. And main thing is in-memory cluster computing. What is meant by in-memory cluster computing? So you have to correlate IoT, cluster, in-memory. So why what is meant by in-memory? So why it has to do in-memory computation? Without in-memory, what happens? In-memory. So always RAM using RAM is faster compared to using any secondary device outside memory. So what it will do is it uses in memory, faster computation, huge volumes of data, means real-time data, means mostly from IoT device. So you have to protect all these things. Next cluster, why we need cluster? Because huge volumes of data is still node cannot handle. So we are forming a cluster of various processes. And then when we cluster it, we need to take care of load balancing and node schedule. And second one is this one. What is that? In memory. So what is in memory? Rather than moving data from secondary device ROM to RAM, it uses inside memory so that the data transfer is reduced. The aim is to reduce the processing time. The output must be faster. So which are the things leads to means delay the processing to the eliminated. So they want to process everything in memory. So now, if they want to efficient in-memory management, which are all the techniques they have to adopt? In-memory is RAM. Now, efficient RAM usage need various techniques. What are those techniques? In architecture? No, I am not talking about the architecture. See, in-memory processing is a critical requirement to process faster. To achieve faster in-memory management processing, two techniques are there. In that, what are the main techniques we need to take care? Which one like? Cache memory organization. Cache plays a major role. Okay, so you need the cache organization, it's not the memory. I'm going to refer, the CPU going to refer. You need to bring it to the cache. So to achieve in-memory management, cache management plays a major role. Like that you have to relate. Okay, next. So what is PySpark? As I said, why Python is becoming too successful for every application, for every open source, it provides an API. So if you don't know how to talk to Apache Spark, Python is having APIs available so that you can talk to Spark using Python. APIs are available. What is an API? It means what? What is APIs? Building functions. So building functions are available. Using that function, you can perform same function. Yeah, even though I don't know how to talk to Apache to processing the huge volumes of data, but if I know Python is having APIs. We can just call the API, it will do the same task. Clear? See, you can write arrays, linked list using C++. And you also have STL. What is STL? What is STL? STL. In C++, we have STL. What is STL? Standard template library. Their array is available, linked list is available, queue is available, everything is available. You don't spend any logic. Queue dot insert, queue dot, everything is available. You don't need to write any logic. Same here also. APIs are available. We can call the APIs, okay, and you can talk to the Spark. Okay. So PySpark is the Python API to use Spark. Okay. So PySpark is a Python API to support Python. By using Python, how I can use Apache Spark. PySpark provides PyTorch library. Okay. With the help of the library, Python can be easily integrated with Apache Spark. So when it is easily integrated with Apache Spark, if I know Python, the complexity is reduced. So by using Python, now I can develop real-time applications where I can process huge volumes of data. So how many of you from fourth year or third year? Which year you are? second MCA, MSc, completed C++. So there you have studied SQL, standard candidate library. So what SQL will do? Everything built is available. Array is available. Stack is available. Linked list is available. DQ is available. So no need to write any code. List dot reverse, CQ reverse. Same thing, API. Okay, so just install, just import py4j. By importing py4j, we can use all the libraries available for Apache Spark through Python and process the real-time data. Okay, so PySpark plays an essential role when it needs to work with a vast data set or analyze them. This feature of PySpark makes it very demanding tool among the data engineers. So when you want to deal with huge volumes of data, okay, easily, so you have to use PySpark. Through APIs, just import py4j, then all the APIs are available. Using those APIs, you can process the huge volumes of data. Next. So what are PySpark features? In-memory computation. See, main is in-memory computation. Okay, because I'm dealing with huge volumes of data to and fro, in and out of the data to in a RAM, then to ROM, it will take time. Instead, if you think in the RAM with efficient cache organization techniques, I can process huge volumes of data. So if you want to design those kind of tools, so these are things we will take. First is what in-memory computation. For any faster output, we have to efficiently manage the memory. What's the next one? Lazy evaluation. Fault tolerance. Okay. Second, immutability, partitioning, persistence, coarse grained operations. So any doubts? Lazy evaluation means it will wait. So if there is a computation, what it will do, suppose one operation, if I am going to use it later, so it won't do it immediately. So whichever operations now I need to use, next step is available, I will use it. I will process it. Suppose express y. Next statement I am using x square. Next statement I am using x cube. So it will compute all these things first, then it will compute x. Keeping hold to compute it later, we are calling it as a lazy computation. These are the efficient costing techniques, memory management techniques. Okay. Next. So real-time computation. PySpark provides real-time computation on large amount of data because it focuses in memory processing. It shows the low latency. What is latency? Output. Because of in-memory, automatically speed will be high. So latency will be. So suppose multiple languages. So not only Python, Scala is also having APIs. Okay. Next, Java, Python, Scala, R. So all these languages are having APIs of Apache. So by using these languages, not only Python, you can use Scala or Java. So I will study Java. Java is also having this standard library. Okay. So next is catching and the constancy. Main thing is what? PySpark provides powerful catching and good response. Catching is what more important. What are things need to be the catch, need to be the memory, need to be the disk. How to move it with less movement from disk to catch. Okay. So if it is not in the memory, it must be in the cache. That's how you have to design the algorithm. Swift processing. Okay. So PySpark allows to achieve a high data processing speed, which is about 100 times faster in memory and 10 times faster on the disk. If it is memory, very fast. 100 times it will do faster. If it is disk, 10 times. Okay. Next. So there is RDD that we will see. What is RDD? we'll see later. Next. So Spark, so need for powerful engine that can process the data in real time as well as batch mode. Batch means it is there in the data set, database, I will take batch by batch and process it. And real time means sensors are there, they will send the data and they will keep on sending data to the server. So we need to get the data and we need to process it. Okay, in both the cases, Spark is useful. Next. So Apache Spark is a powerful open source engine which will handle same batch processing, real-time data, interactive data, graph data, next machine learning, thing. All kinds of problems you can solve with help of machine learning. See, machine learning what happens, you want to predict the output. Okay, you will train. But for training, you have 1 crore rows. So how you will train? Obviously, if that high data is there, you need to bring in PySpark. Using PySpark, you have to data is there. PySpark, you need to train the model. Batch processing, you are taking only 32 or 42. You may have only 30,000 data. Here, you may have to bring 1 crore data. So 1 crore data, how you will process with the help of a PySpark. Okay, that is what it is. So by using PySpark, 1 crore rows, you will train the model. How you will train the model? So if you use PySpark, then how efficiently you can train the model. Okay, so machine learning iterable. So how it is iterable means, so you will take at a time maybe 10 lakh rows or 20 lakh rows to train the model, and another next on top of it train another 50. So that's how iteratively they will train the model with huge volume. Okay, next. Okay, so provides point done. So you can use Scala also. So how many of you know Scala? Scala. See, Python, how many of faculty? You must know the languages which is not there in the curriculum. So you must know Scala, Julia, R, Python, so that you can be able to learn multiple perspectives, how each problem, which one is better, how Scala is solving the problem, how R is solving the problem, how Python is solving the problem. So Scala, okay, Julia, all these things are same, related to statistical processing of the data. So Julia is also one of the language which will process data, similar to R. So a lot of packages are available, and you can import those packages and you can process. Okay. So history, just theory. Okay, so started 2009, then open source in 10. Okay, then it went to Apache. Okay, so most active project in Apache. Just theory. Next slide. Okay, see here. So how Hadoop will process the data and how Spark will process the data. How much time computation, time comparison between MapReduce and Spark. So how it reduces the processing and how much data size, time taken, number of nodes, number of CPU cores, okay, clusters and network. So almost in every case, okay, how many nodes and what is the time? So Hadoop needs 2100 nodes. Okay, whereas the same data can be processed by Apache Spark with 206 nodes. And how much time it will take? 72 minutes for Hadoop and 23 minutes for Apache. But first Hadoop is the first distributed processing tool. Okay, later Apache came and see almost 1/4, 1/5 we can reduce the time. Okay, next. See, so what are the goals? Easy to combine. Either it will be a batch processing or a streaming and interactive computations. So with single platform. We can do any kind of input data, whether it's continuously receiving the data or it's already there in the database, how to fetch it in a batch mode and interact. So interactive means as and when we get the data. So when the user interacts and provides the data, then we need to process the data based upon the external party interaction. Streaming means continuous delivery of the data. And what is that? Batch mode means static data, which is available in the database, but huge volumes of data. Okay. So why Spark? 100 times faster than Hadoop. Faster. Okay. Because of real-time deployment, okay. So we are deploying in autonomous driving, deep learning and machine learning models. Okay. So when we are deploying in real-time environment always expects the faster output with more accuracy, with little bit compromise is okay. Okay, because of deployment in real time always expects faster output. Okay, that's why Spark is more demand compared to Hadoop. Okay, so how see here? So what Hadoop will do and advantage is in-memory computation. See here, Hadoop everything the data is stored in the disk to operation. So whenever I need to perform express y, I will get x and y from the disk. In case of Spark, RAM in-memory computations. So we are using RAM. So RAM is always faster. And see here, whenever, next slide, see here, disk, I am performing operation 1, then storing the data in disk again. Then for next operation, again I will get data from disk 2. Then store it in disk and operation. If you see here, in case of from disk, I got the data and I put it into RAM. Okay, next operation, get it from RAM. All operations we will perform in memory computation. Once all the operations are completed, then the data is put into the disk. So whenever disk is involved, there exists a high latency. So data must be stored to disk and get the data back. In case of in-memory computation, it's faster. It is available within the system, CPU itself. So how many times I talk to CPU, it doesn't matter. But if I talk to connect to the disk, there is a problem. Okay? So that is what the difference between Hadoop and Spark, why it is more faster compared to Hadoop and other earlier systems. Okay, next. So language supports like Scala, Spark can be implemented not only through Python, you can use Scala or Julia Python also. But Python is widely used in almost all the applications. Not only distributed in natural language processing, machine learning, deep learning, data processing, all the areas, audio processing, array processing, numerical processing, all kinds of data processing, Python is serving APIs. Hence, Python is more widely used in industry. Okay. So, support real-time and batch processing. So, input data as a string. Okay, Spark stringing will be there, and it will split into batches of input data, and then you can process it. Okay, so range of operations, optimize the job before execution. So rather than the instructions given by the user, those set of instructions it will analyze and try to optimize. Suppose A equal to B plus C, E equal to B plus C plus D. How to optimize? C equal to A plus B, D equal to A plus B plus C. How to optimize?
C equal to A plus B. C equal to
C equal to A plus B. Okay. Next, D equal to A plus E equal to A plus B plus D. How to optimize? C, first is C. C equal to A plus B. So this is a simple example, but like this, there will be complex set of operations where there is a scope of optimization which will reduce the connecting to the memory, getting the data from the memory. So again, we see in how to storage service and get the data from this first C. Instead, what it is doing is D E equal to C plus B, which is equal to A plus B plus D. This is a simple example, but like this, like a lot of optimizations are available so that we can be able to optimize the code, okay, which we are calling as a lazy execution. Okay, so all these are the features of Spark, which makes it more faster compared to the other existing networks. Next. See here, so support for multiple transformations and actions, so that we will see later. Okay, so how it will perform the operations. Okay, RDD, I will explain later. Next. See here, Spark nodes. So there will be node, master node, and slave nodes. So master and worker. So master just is a controller, like a principal. And masters are, these workers are faculty. So just distribute the load and he will monitor. Same. Master will monitor, workers will execute. They will coordinate. So like the number of worker nodes, they will parallelly process the data. Okay, any node failure, automatic transfer of the data. Suppose I allocated some data to node C, but the system got failure, node got failure. How automatically get the data and get it to process to another node. So all these things will be automatically taken care without any manual intervention. That is advantage of Spark. Okay, so cluster is collection of worker nodes, and there will be a master node that will control the processing of data, distribution of data, monitoring of the worker nodes. Okay, resilient distributed data set. Okay, that will see data. Okay, so this is what a brief introduction to Spark and why we need to Spark, advantages of Spark, how it is different compared to other distributed processing systems. Okay, so what are the techniques it will follow? Lazy optimization. Okay, in-memory computation. So makes all these things makes it faster and efficient compared to other things. Okay, we'll take a break. And we'll 11, we'll take a break. Okay, then I will discuss about RDD, then we'll go for demo. This is theory, okay, you can read anywhere. I will show 3 demos, okay, then you can get an answer.
From there we take the photo. From last, we can begin. No problem.
ಸರ್ ನಾವು ಟೀಗೆ ಹೋಗಿ ಹೇಳಿದ್ರು
ಇಲ್ಲೇ ಬರುತ್ತಲ್ಲ
ಬರುತ್ತೆ ಕಾಲ್ ಮಾಡಿ
ಇದಕ್ಕೆ ಟೈಮ್ ಇಲ್ಲ
ಒಂದು 1/4 ಗಂಟೆ ಕೊಡಿ
ಟಿಫನ್ ಮಾಡಬೇಕಾ ಟಿಫನ್ ಆಗಿಲ್ವ ನಿಮಗೆ ಆಯ್ತು ಆಯ್ತು
ರವಿ ಅವ್ರು ಕಾಲ್ ಮಾಡಿ ಬೇಗ
ನೋ ಪ್ರಾಬ್ಲಮ್ ನೋ ಪ್ರಾಬ್ಲಮ್ ಅದು ಫೋಟೋ ಕಳಿಸ್ತೀನಿ 768081 ಇನ್ನೊಂದು 8887
Thank you.
ಕೀ ಬಂತು.
ಸ್ವಲ್ಪ ಕಟ್ತಿದ್ದೆ ಈಗ ಬರುತ್ತೆ ಆರ್ ಟಿ ಒಂದು ಲೆವೆನ್
The first time I'm attending this is the first time.
Okay.
Can I use this video advice machine learning this section?
So in machine learning, you have to how to train the model with huge volumes of data. 1 crore of data is there. 1 crore. Suppose if you want to train the model with say weather conditions or stock price prediction or next day next day what are the suppose
ಪ್ಯಾಕೆಟ್
DMart.
ಇನ್ಚಾರ್ಜ್ ಇಲ್ಲ ಆ ಸೆಕ್ಷನ್
All the Sunday data. So next Sunday, what are the products are in demand? So I want to predict that. For that prediction, each Sunday, we may have almost say 10 lakhs or 15 lakhs of data. So how we could train that? Faster. So in those cases,
We are using only 5,000, 6,000.
5,000.
So that
But if you want to work with astronomical data, say 20 crores of data, you have to train with the 100 columns. 100 columns, 10 crores. How to train? So you have to do now new work differently. You have to work on.
for huge data. Anyway, we'll see with them.
ಬರ್ತಾ ಇದೆ ಅಂತ.
ಸೊ ನೆಕ್ಸ್ಟ್ ಏನು ವಿಡಿಯೋಸ್ ಪ್ಲೇ ಮಾಡಬೇಕು
ಕೂಡ ಇಲ್ಲ ಫೋರ್ ರನ್ನಿಂಗ್ ಮೇಲೆ ಮತ್ತೆ ಇಲ್ಲ
ಇಲ್ಲಿಂದ
ಅವ್ರಿಗೆ ಸ್ವಲ್ಪ ಮುಂಚೆ ಆಗಿದ್ರೆ ಚೆನ್ನಾಗಿ ಕಾಣಿಸ್ತಿರ್ಬೋದು
ಏನು
ಸ್ಕ್ರೀನ್
ಸ್ಕ್ರೀನ್ ಅರ್ಥ ಆಯ್ತಾ ಬೇಕಾದ್ರೆ ಇನ್ನು ಮುಂದೆ ಹಾಕೋದು
ಅದೇ ಚೆನ್ನಾಗಿರುತ್ತೆ
ನೋಡ್ಲಾ ನೋಡ್ತೀನಿ ಅದು ಯಾಕಂದ್ರೆ ಕೇಬಲ್ ಐತಲ್ವಾ ಅದಕ್ಕೆ
ಸೊ ಇದು ಸ್ವಲ್ಪ ಮುಂಚೆ ಆಗಬೇಕು
ಯಾವುದು
ಸೀಟ್ಸ್
ಹಾಂ ಓಕೆ ಶಿಫ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ
ಫಸ್ಟ್ ದಿನ ಯಾರು ಗುಡಿಸೋದು ಬಂದಿಲ್ಲ ಫಸ್ಟ್
ಹಾಂ
ಫಸ್ಟ್ ಯಾರು ಬಂದು ಚೀಫ್ ಗೆಸ್ಟ್
ಬೆಳಿಗ್ಗೆ ನಿನ್ನೆ ಬಂದಿದ್ದೆ
ಯಾರು
ನಿನ್ನೆ ಮೊನ್ನೆಯಿಂದ ಬಂದಿದ್ದೆ
ಇಂಡಸ್ಟ್ರಿ ವಿಸಿಟ್ ಇಲ್ಲಿ
ಸರ್ ಇದು ಸ್ಕೆಲ್ಲ ಸಾರಿ ಸ್ಕೆಲ್ಲ ನೀವು ಹೇಳ್ತಾರಲ್ಲ ಸ್ಕೆಲ್ಲ ಅದನ್ನು ನೋಡಿದ್ರೆ ಸರ್ ಮಾಡ್ತಾರೆ ಈಗ ನೆಕ್ಸ್ಟ್
ಬಿಸ್ಕೆಟ್ ಒಂದೇ ವರ್ಷ
Apache, PySpark, both are same. Both are same.
Apache PySpark will give the interface through Python.
ನೀರೇನಾದ್ರು ಬೇಕಾ ಬಾಟಲ್
You want tea?
ನಿಮ್ಗೆ ಬೇಕಾ
But they said the CAD lab immediately. No, this is T, section T. ಟಿ ಸೆಕ್ಷನ್ ಓಕೆ ಓಕೆ ಮೇಡಮ್ ಸರ್
ಹಾಂ ಬೇಡ ಬೇಡ ಕುಡಿತೀನಿ ನಾವು
ಇಲ್ಲ
ಸರ್ ಬಿಸ್ಕೆಟ್ ಕೊಡ್ಲಾ
ಮೇಡಮ್ ಸಾಕು
ಮಾರಿಕೊಡ್ತೀನಿ ತಗೋತೀವಿ ಮಾರಿಕೊಡ್
ಆಯ್ತು ಮ್ಯಾಮ್ ಇಲ್ಲ
ಆಯ್ತು ಅಲ್ಲೇ
ಓಕೆ ಅದು ಎಲ್ಲ ಪ್ರೊಜೆಕ್ಟರ್ ಡಿಸ್ಪ್ಲೇ ಮಾಡ್ತೀನಿ ಬೇಡ ಅಂತ
ಸಾಕು ಮೇಡಮ್ ಸಾಕು
ನೆನ್ಸ್ಕೊಳ್ಳಿ
ಸಾಕು ಸಾಕು ಸಾಕು
ಇಲ್ಲ
ನೀವು
ಬೇಡ 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 ಬೇಡ
ಸೊ ಇದು 1 o'clock ಎಂಡ್ ಆಗುತ್ತಾ
ಸರ್ 1:15 ಎಲ್ಲ ತಗೊಳ್ಳಿ 15 ಮಿನಿಟ್ಸ್
ಫಾರ್ಮಾಲಿಟೀಸ್ಗೆ ಒಂದು ಇಟ್ಟಿದ್ದಾರೆ ಅವತ್ತು ರೂಲ್ ಒಂದು ಎತ್ಕೊಡು
ಬೇಡ ಬಿಡು ನನ್ ಬೇಡ ಬಿಡು
ಅಲ್ಲಿ ಖಾಲಿ ಆಗಿದೆ
ಬೇಡ ಬಿಡು
ಯಾಕೆ
ನಿನ್ ಬೇಕಾದ್ರೆ
ಅಲ್ಲಿದೆ ಒಂದು ನನಗೆ
ಸಾಕು
ಈ ತಗೋಪ
ಬೇಡ ಬೇಡ
ಕೊಡು ಮಧ್ಯಾಹ್ನ ಇರ್ಲಿ ಬಿಡಿ
ಮಧ್ಯಾಹ್ನ ಇರ್ಲಿ ತಿರ್ಗಾ
ಇಲ್ಲಿ ಊಟ
ಸರ್ ಅಲ್ಲಿ ಈ ಸೈಡ್ ಲಾಭಲ್ಲ ಅದು ಹೆಂಗೆ ಮಾಡಿದ್ರು ಮಧ್ಯಾಹ್ನ ಬರುತ್ತೆ 1:15 ಅಷ್ಟೇ ಬರುತ್ತೆ
ಇತ್ತು ಒಂದು
ಅದೇ cool.
ಅದು ಮೂರ್ತಿ ಚೇಂಜ್ ಕಲ್ತಿದ್ದಲ್ಲ ಅದೇನೇ ಖಾಲಿ ಬೇಕಲ್ಲ ಬೇಡ
ನನ್ ಬೇಡ
ಬ್ಯಾಗ್ ಏನು ಕೊಡಲ್ವಾ
ಸರ್ ಏನು
ಬ್ಯಾಗ್
ಯಾರಿಗೆ
ಸ್ಪೀಕರ್
ಸರ್ ಬ್ಯಾಗ್ ಎಲ್ಲ ಮೂಮೆಂಟ್ ಹೋಗ್ತೀವಿ
ಮಗು ಕಣ್ಣದು
ಅದಲ್ಲ ಅದು ವೆಲ್ಕಮ್ ಆಮೇಲೆ
ಎಂಡಿಂಗಲ್ಲಿ ಮೊಬೈಲ್ ಕಣ್ಣದು
ಮೂಮೆಂಟ್
ಬರಕ್ಕೆ
ಸರ್ ನೀವು ಸ್ವಲ್ಪ ಟೀ ಹಾಕೋಬೇಕು
ಏನು ಬೇಡ
ಸರ್ ಟೀ ಸ್ವಲ್ಪ
ಬೇಡ ಬೇಡ ಕಣೋ.
ಇದು ಸರ್
ಇದು ಸಾಕು
ಟೀ
ಏನು ಬೇಡ ಜಾಸ್ತಿ ಆಯ್ತು
ನೂರೇನ್ ಮತ್ತೆ ಬಂದಿದ್ವಲ್ವಾ
ಯಾರು
ನೂರೇನು
ನೂರೇನಾ ಬರಲ್ಲ ಅವ್ರು
ಬಂದಿದ್ದು ನೋಡೆ
ಹೌದಾ
ಮತ್ತೆ ಹೋದ್ರು ಅನ್ಸುತ್ತೆ
HOD ಸರ್ ಕೇಳಿದೆ
ಹ್ಞೂ
ಈಗ ಕೋಡ್ ರಿಲೇಟೆಡ್ ಮಾಡ್ತಾರಲ್ವಾ ಕೋಡಿಂಗ್ ರಿಲೇಟೆಡ್ ಅದಕ್ಕೆ
ಏನು ಕೊಡಿಂಗಿಲ್ಲ
ಪ್ರೋಗ್ರಾಮಿಂಗ್
ಇವಾಗ ಅದಕ್ಕೆ ಕರ್ಸಿ ಅಂತ
ಕೊಡಿ ಸರ್
ಹಂಗೆ ಅದೇ
Few-shot learning. By using less number of samples, how to train the model, how to achieve better accuracy. So focusing on feature engineering and focusing on efficient model development.
less number of samples.
Only one sample. Without sample. One shot learning, two-shot learning, three-shot learning, zero-shot learning. Zero number of samples. By looking into the existing features, is it possible to
This feature everything good. Only this happens.
Yes, it's one feature only we have created the model. Only one sample, in that only one feature. That's it.
So, but we are aware of the for deep learning concept. We have to train huge number of data with
No, huge number of data anyone can do. You have to focus on with less number of worst case scenario, how your model performs is what the yardstick. If everything is there, so maybe, a simple model can work. But with less number of samples, with less computation time, how it's possible to develop a model is what we focus on.
ಈಗ ಡೆಮೋ ಡೆಮೋ
One sample in that one feature only. One cross one.
One cross one.
One cross one.
One cross
One row, one column. That is the data.
any data.
We need an image means only one image.
Only one.
Mine is a signature data, one row, 100 columns. But we work around to generate one class one only. So how to reduce the process? Training time, inference time. You have one class 100, but by giving the output, you have to process all the 100. If you have only one feature, you can do immediately. But there is a lag in the accuracy. You should not go beyond acceptable level. So how to achieve that is what we should do.
What's the So we had a query, sir. So
Biomedical.
ಅವೆಲ್ಲ
Cherry could have put him.
That sensor data.
sensor data so that it is that it is
Sorry, really put it.
164, so they reduced this.
ಅದೆಲ್ಲ ಎತ್ತಿತ್ತು so that we can so can we still further reduce because you
Yes,
said that
yes, madam. See, it all depends upon efficient memory feature reduction and efficient model development. To one class one.
So, anyone can summarize what was studied to you?
We have seen what is spark, partial spark, high spark, how it is different from other previously used.
Okay. Next. See, this is the same next. Now people are using Kubernetes, Kubeflow, etc. Same architecture. There will be a master, there will be a cluster, group of workers. Group of workers, what they actually execute the code. Master allocates, monitors, and take care of fault tolerance, automatic, like taking the load schedule, automatic data transfer, load schedule. Complete monitoring will be taken care by master. Real execution of the data, parallel processing of the data will be done by group of workers. Okay, next. Now, how Spark able to do this? Resilient distributed data set. So that is also one of the unique characteristic or property of Spark. So what is RDD? So how to achieve parallelism? We have workers. Workers is a collection of class is a collection of workers. So how to achieve parallelism? If you want to achieve parallel execute the code, what you will do? So to achieve parallelism, so what type of structure we need? Because parallel execution of the code. So now we need to slice the code also, slice the data also. So what Spark will do is, if resilient data, distributed data set, it will make the data ready for distribution. So here what happens? We have RDD. So RDD is a collection of object 1, object 2, object 3, like that we have n number of objects, n number of partitions. So one object or one batch or one partition, I will give it to one second worker, third worker. Like that, I will assign the tasks. So they will keep on executed by the parallel workers, and then they will accumulate the result and they will summarize the result. So, in order to give the data as an input to multiple distributed workers, what I need to do is, I need to slice or I need to patch the data. So, that is called as RDD, resilient distributed data set. So, then only I can slice the data, I can feed it to the workers. So, next. See here. So, user, then what happens? Master, there is a collection of 100 slaves. So what it is doing, for 100 slaves, we are distributing. We are segregating the data and we are feeding. Now those 100 nodes automatically it will work. It is not hardware, completely software. If you have two Linux machines, those Linux machines, if you can run some set of codes, automatically a master will be created. This system will be the worker. So it's not hardware, it's a pure software set of instructions you need to run so that you can form a clusters. So if you want 100 clusters, you need to have 100 Linux machines. And you need to choose a high-end machine or a low-end machine. Which end machine you need to choose as a master? Which end machine you need to choose as a master? A high-end machine means high configured memory or low. Why? Because actual processing is done by the worker nodes. So under high-end memory, you can take as a workers, a low-end GPU memory can be used as a master. Okay, so you have run some set of codes, instructions, some bash, something will be so set of instructions. If you run automatically, the machine where you run the master code, it will become master. Where you run the slave code, it will become slave. and then you can execute Python line, Python.py. Automatically it will run. Okay, it's not magic. You have to run some set of instructions. That's it. Then you can form the group. Okay, so RDD means what? To achieve parallelism, to process by n clusters, n workers, we need to partition it. So the data sets we are calling as a RDD. Next. So see here. So say RDD objects. It can be a Python object, scalar, or Java. Any object I can allocate to the node to process it. Next. See here, RDD is a set of partitions. So each partition I can give it to each node. Automatically it will process it. So because n partitions, yet one unit time, all partitions will process the data. So I am getting output from one unit time only. No need to wait for n units. Okay, next. See here. So we need to, from the existing data set, we need to create the RDD. So what is RDD? RDD is a set of partitions. Once you made the partitions, you can pass on to the worker nodes. See here. So to perform once the RDD is done, okay. So which are operations you can perform? Transformations, actions, and persistence are the three types of actions which we can perform on the worker nodes. Because we segregated the data, okay, but the data means all the rows, but all the rows is not possible to process at a time. So what we did, we partition. So we have to take extra steps so that we can summarize those data. So which are the operations we need to perform? It contains three types. One is transformations, actions, and persistence. So go through it. What is transformation? So set of operations that define how RDD should be transformed, how to create those partitions. I have a unit single data set, how I can partition it so that I can distribute to the workers. Okay, creates a new RDD from the existing one to process the data. So lazy evaluation, map, flat map, filter, union, group by. So these are all operations, commands I can use in order to convert a single database into set of partitions. What about the next one? Action. Yes. So what we need to do is trigger the job. Actually, we need to transfer the job. So return the result or write it to the storage. So first trigger it so that the workers will execute, and then we need to get it back. So count, collect, reduce, pay, etc. Okay, distribute, then take the result from multiple nodes, summarize it, so those are the few keywords, key commands which we need to use once we distribute it to get the data back from the workers. Okay, last persistent. So Spark allows, then we need to catch it. Once we get the data, we distribute it, we got the data, then we need to persist it. So Spark allows catching or persisting entire data set in memory. So catch the RDD will be for future operations of the next pipeline. Okay. So these are three steps. Go to back previous the transformation set of operations that define how RDD should be transformed. I have data set, how I can transform it so that I can pass it to the multiple set of nodes. Second one is to create a new RDD from the existing data set. Okay. Okay, so map, flat map, filter, union, group by. So these are the few of the operations I need to work on. Next, action. So once it is done, once I triggered, I need to collect back. So count, collect, reduce, okay, then take. So these are the keywords. Okay, next. So once I get the data back, on processed data, I need to store into the database for the next pipeline. So for that, next slide. So Spark allows catching or persisting entire data set in memory, catches the RDD in the memory for future operations. Next. Okay, so see here. So we have various set of RDDs. So we perform a set of transformations. Once the transformation is done by using map, various commands like map, okay, so flat map, etc. Then we will perform the actual action on the data. And once action is done, so for action, see here, returns output for to driver or export data to storage system after computation. So first we will create the RDD, and then we perform action, and then finally we store it as a text file or whichever format we need, we will store the data. Next. That's it. So this is what, in brief, complete end-to-end theory introduction about what is Spark, what is Apache, what is Spark, and what advantages compared to previous existing engines, and with all the techniques, I Spark, in order to the okay. And then there are two data sets and we transform into a format so that it can be split into the worker blocks. So what is that RDD? So how to achieve that? By performing transformations, actions, and persistence. So this is how you distribute into the worker nodes, get the data back, and store it into the. Okay. So any doubts? Complete IoT. When you want to deploy IoT application in any field, sensor data. Okay, if you are sensing anything, by deploying sensors, you will receive data and keep on pushing into the system. You have to receive data and you have to process. So wherever every second per